This video is going to cover the topic of similar figures. Be sure the date and topic are at the top of your page. The essential question for this video is, how do we identify similar figures? These two images represent a pair of similar figures. These two figures represent a pair of non-similar figures. So we're going to look at these and see if we can determine what makes two shapes, in this case triangles, be called similar. For similar figures to be called similar, they must have the same shape. So in example number 1, let me call this one number 1, and we'll call the other one number 2. It looks like both triangles here have the same shape. I have triangle ABC and triangle DEF. They appear to have the same shape. When I look at example 2, right, I'm just looking at the way they look. This also looks like they have the same shape. I have no reason right now to say anything other than that. They also look like they are the same shape. Similar figures also have the same angle measurements for corresponding angles. So in example 1, angle C corresponds to angle F, so those should be the same measure, right? Every single angle in your figures should be equivalent. The corresponding angle should always be equivalent. Now, since the angles in all of these triangles are not actually labeled, we can't check that. They certainly look like they are the same size here, but I just put a question mark since they're not labeled, and we can't assume anything. We want to make sure we don't ever just assume because they look the same that they are the same. Since the angles aren't measured here for us, we're just going to move on to the next criteria. And that means I'm going to start to look at the side lengths of the corresponding sides. So I've listed all of our corresponding sides, and I'm going to start to analyze the lengths here. And what I notice is that DF is 5, and if I multiply it by 2, I get the value of AC. DE is 3, and if I multiply that by 2, I get the value of AB, the corresponding side. And EF is 6, and if I multiply that by 2, I get the value of its corresponding side, BC, which is 12. So what I'm noticing here is that in our example for similar figures, each side was multiplied by the same amount to figure out the length of the corresponding side, or when you're kind of connecting the two together. Let's look at the same thing for our example on number 2 that I've already told you is not similar. So I have my corresponding sides laid out again here, and I know AC is 6, and I'm looking and I know that it has to get to 18, and I notice that if I multiply that times 3, I get the corresponding side of 18. If I do the same thing for AB, that's 5, and 5 times 3 makes 15, which is the length of DE. What I notice now, though, however, BC is 4, and BC times 3 is 12, and that is not the side length of EF. So that does not match up. And so I'm just going to make a note here that in our non-example, when they were not similar, the side length was not multiplied by the same amount. And that's the big difference here, right? That is one of the criteria that qualifies two figures as, quote, similar. And just looking at these pictures, right, I might have thought that they were similar, but just looking at the shape is not enough to determine if two shapes are similar. So I'm going to recap the criteria that we need to look for. So even though just looking alike is not enough to call two things similar, they do have to have the same shape, right? That doesn't make it automatically true that they're similar, but if they don't have the same shape, it's a non-starter. They're definitely not similar. So they have to have the same shape. In addition, when we're looking at similar figures, when we match up all the corresponding angles, which is something we've certainly practiced already, but when we look at those corresponding angles, they need to be congruent with one another from one shape to the next. And of course, what we saw most notably in the examples on the previous slide were that all the corresponding sides have to grow, essentially, by the same amount. So if one side is getting doubled to its corresponding side, that means all the sides have to be doubled. And there's actually a term for this, the amount that it goes up by, and that is our scale factor. So I'm just going to make a note of this as well, something we're going to circle back to a lot. And the scale factor is whatever that number is that you are multiplying by. And it's always multiply. I know sometimes we're going to want to divide, but it's always multiply. But it's the number used to multiply the lengths of a figure to stretch or shrink it. So in example number 1, all the sides were being multiplied by 2, so therefore the scale factor was 2. All right, so now I just have a quick sketch of 2 rectangles, and we're just going to go through and check off that these are, in fact, I hope, similar. That's the idea here. So first of all, they have the same shape. That's nice and clear. On this one, these are rectangles, and so I didn't mark the corresponding angles, but since rectangles all have 90-degree angles, that by default would mean that angle B here and angle F are congruent, right? They all have the same angles. And so the last check is to see if the corresponding sides increase by the same scale factor. So I'm going to use AB here as my example, and it corresponds to EF. And it looks like this was multiplied by a factor of 3. So my scale factor here might be 3. Just trying to put 3 here so we have that. So it might be a scale factor of 3, and so we just want to check that that's the same all around. So 4 times 3 is 12. 3 times 3 is 9. 4 times 3 is 12. And 3 times 3 is 9. So all the corresponding sides increase by the same scale factor. So that's a check. Those are all true. So that means these 2 shapes are similar. Now, the examples I've given today are all pretty friendly in the sense that they're all orientated in the same way. Nothing's needing to be rotated or flipped around to compare. We'll of course add to that when we do more in class, but I just wanted you to see some pretty basic examples so you can kind of get an idea for yourself what it is you're looking for. And we saw a really clear example and a clear non-example of similar figures. And remember the essential question was how to identify it. So now we have 3 criteria that we can go through when we are doing that. And we also have this new term scale factor that we will be using a lot as well. So be sure to bring your notes and any questions you have to class.